Peter and I are going to try and build a new drive mode for Rover. In particular, we're going to try and port over the SmartRTL flight mode from copter to Rover. So we're going to run through the steps, and hopefully it'll be a useful feature and also educational for people who want to know how to write Rover drive modes. Okay, so I will start sharing my screen now. See if I can figure out how to do this. There we are. Okay. Alrighty. So Peter, you're still there? Hello, hello. Maybe you're muted.
Still here.
Okay. So yesterday we wrote this wiki page here. So you can get to it by going to rtpilot.org and then clicking on docs. Then well, let me just do it. Click on docs. Then you can click on developers, and then learning the RGPilot code base. And then down here, there's this new page, Rover, adding a new drive mode. So basically, we're going to go through the steps that are listed on this page. And before we started the Hangout, Peter and I were thinking of a script, and or rather the steps that we're going to go through to add this mode. And the first step we're thinking is that we're going to just create a new mode. So go through the just the basic steps of creating the files, etc., to add a new mode. And then we're going to go into the probably much harder part, which is actually modifying the SmartRTL library so that it works with Rover. So that's going to be things like modifying the library so that it works in 2 dimensionals instead of 1. Wiring it into Rover so that the positions are stored every 300 milliseconds, and the testing part. So that's what we're going to do. All right, so I'm on Windows. Most developers are on Ubuntu. So anyway, I use Eclipse for my compiling and editing, and I test on a virtual machine. So the first thing that I do is in my own repo. So I've got an R9 RTPilot repo. I have this master branch. I make sure that it's up to date with centralized RTPilot server master branch. Then I create a new branch for this feature. So we're going to call it Rover SmartRTL, I guess. As that. So now we're in this creating that new branch. And then we can go through our steps. Peter, feel free to jump in at any point if you want to give me advice or whatever. So let's just have a quick look at this page that I wrote yesterday and see what it says at the first step. All right, yeah, so pick a new name for the new mode. So that is obviously going to be SmartRTL, and we need to add it into the defines.h. So let's do that. So RGPilot defines.h, and here's our new mode. So we need to take it somewhere. We've got a couple of these slots here. It can go anywhere. RTL is 11, so maybe I'll make it 12. Next, define a new class in the mode.h. So easiest to copy an existing similar mode and just change the class name. So that would make me think the regular RTL is probably the one. So we go to mode.h. And this is where we have all the interface for all of our classes defined. So we're going to look for RTL. They're in alphabetical order, I believe. Here's RTL, regular RTL. So we'll just grab that and RTL. Well, that's technically it should come after mode steering to be in perfect alphabetical order. But maybe I'm just going to stick it right here. Oh, SmartRTL, like that. Got a mode number, so it's going to be this. Oh, really? Michael tells me that my voice is almost incomprehensible. Some people are saying the voice is not good. Don't know what to do about that. Anyway, I'll just keep going, I think. So we got, actually, let's just make sure, what do we call the flight mode in copter? Or SmartRTL 01. Let's have a quick look here. Smart_RTL. Maybe we'll do the same here, just to be consistent. That. All right, and so here, I think here we'll just call it SmartRTL with no. But in copter as well, we also have the underscore there. So let's. And I'm going to leave the underscore out. Okay, so then here, we also have a name for the mode. What do we call it under? What do we call it in copter again? In control. Search for. Now we have come up with a 4-letter string for that. So here, control modes and commands control. Flame modes, there it is. SmartRTL is here. Just a little. But I want to make sure it's consistent with copter. Right, so we're getting a couple of reports that nobody can hear us. Right, so we're getting a couple of reports that nobody can hear us. Oh, so we're getting, that's a. Let's just do a quick pause here then, and we're going to see what we sound like on YouTube.
Yeah, I can actually understand you, but yeah, your audio is actually having significant issues. Is there anything that might be using your upstream bandwidth?
I can't think of anything really. Nothing really going on. Well, we could have. Really? Peter comes through okay. Well, that's unfortunate. I'm not sure there's much I can do about that, really.
Do you want to just pop onto Mumble and we'll just see if your audio is fine on Mumble?
Yeah, sure.
So if you could just, if somebody else could help, Randy Test, somebody's just at the door.
Hey, Mike, can you hear me okay?
Just a second, please.
So it's the audio on, it's not like the audio is broken on my
Hi.
computer.
Sorry, I'm on a conference call. Thank you very much.
Yep. So, how do I sound now? I still have the broadcast right on the YouTube. Ah, here we are. So now you can see me again, probably.
Yeah, am I unmuted at the moment?
Yes, you're unmuted. So how's my voice now?
No improvement, I'm afraid.
Oh, really? That's a bit surprising.
Yeah, Michael's got a fair point. Try disconnecting Mumble.
Okay. So mumble's gone now.
Much better from my perspective.
Is it? Is it better? Any better?
Yeah, much better.
Really? Really? Something is, yeah, totally chewing my CPU here. I see. Yeah, my CPU is 100%. Windows
I did notice you were compiling stuff there.
Yeah, I was compiling. Maybe it's compiled. It's done. No, it's still compiling. I could try it, but you can hear me okay now?
Yep, it's perfect to me.
Better.
And,
Weird. It was mumble. That's a shocker. Well, I hope I can edit this video a bit later. If not, you'll have to put up with us faffing about. Anyway, okay. Okay, let's get back on track here then. Oh, I've also stopped screen sharing though. Maybe it was the screen sharing that made things better. Let's try screen sharing and see if that breaks the video. Now, is my video still okay? Hello?
your audio, I think you're referring to, and
yes,
it's
my
good
audio.
so far.
Yeah, still fine. Alrighty. Okay, great. All right. Well, that was a little bit of an education there. All right. So back on track here. So what we were trying to do was continue setting up the skeleton inside of Rover. So we need to come up with a little 4-letter string for this flight mode. So I'm just going to call it SmartRTL. The skeleton inside of Rover. Oops. We need to come up with a little 4-letter string. Mute. There we go. Lewis is getting a little feedback from me there. A little echoing. Okay, it's great. So we've got that done now. What else do we need to do? Right, so here's the update function. This is the one that's going to get called 50 times a second. Then we have some other attributes that we might want to fill in, like is it an autopilot mode, which we just leave as true. Failsafe throttle suppress, which actually doesn't appear to be used anywhere, so we're going to cut that out. We've got this get distance destination, so we're just going to leave that. And then a reach destination. So we're going to leave that the same as as regular RTL. So that looks pretty good to me. Right, okay, and so then the next steps in terms of adding a new mode, right? We've gone into the mode.h, we've already done this. We've done all of step 2 now. Now we need to create the new mode underscore something something CPP file. So we're going to, again, copy the mode RTL CPP file. Let's just do that. So we're going to come in here. In Rover, we're going to find mode RTL. We're going to copy it. Guess we can paste it. Give it a new name, which is going to be mode SmartRTL with an underscore. Better or worse, it's got one. Okay, called mode SmartRTL is the name of it, right? And that obviously needs to match this. That. Just going to rename all these 2 functions here. Okay. And what else do we have to do? Yeah, so this update function, I guess, well, actually, we've got 2 functions that we need to work on. There's the enter function and the update function. So the enter function is the one that is, excuse me, called when the user switches into the mode, from the transmitter or whatever. So any initialization that we need to do, we should do inside this enter method. And then the update function, this is the one that gets called 50 times per second. This is where we do things like interpret any pilot input, which we probably won't need to do for an RTL because it doesn't take pilot input. And then we also need to do things like update the targets if necessary and make calls to our steering and throttle controllers. So these are the two things that we need to do. So yeah, so in our enter, what are we doing here is, right, so we are failing to enter the SmartRTL mode if home has not been set yet. So that seems reasonable. Then we set desired location. So this is a sort of general function which is implemented inside the mode class. It sets all the origin and destination for navigation controllers. So that seems like a good thing to leave as it is.
Yeah, Randy, your
yeah.
audio is suffering again.
Oh,
Your
really?
audio is very suffering.
Really? So it's not mumble then? Well, maybe this is just not going to work. Maybe it's not going to work. Maybe it's... I get rid of something on this machine.
Perhaps if you can control that compilation process, if you cut the number of parallel tasks down.
So I just canceled the build. There's actually really no reason for me to be compiling right now anyway. Does that make it any better?
No, it hasn't helped, in fact.
Has not helped. I wonder if I can, if I've got some other windows open here that I can get rid of. Your screen sharing. Let's present to everybody button. Doesn't do anything, does it? Okay. Well, all right, we'll give it another try. If this fails, then what we'll do is we'll instead just try to we'll do a hangout for the people who want to be involved live, and then we'll just record it with a separate recorder, and then we can put that on the on YouTube instead.
Suggestion you close Skype.
There's a good one. Okay. Hello, does it make it any better? Any better? Yes, no, maybe. I can close Getter.
Still no better.
Getter. Get rid of this because it's got my. There's really nothing left. My CPU usage is down a bit. No better, no better. I wonder if I can control if there's some way that I can control something. Adjust bandwidth usage. Video visuals, disable HD, how about that? Does that make any better?
There's a suggestion that Mumble may have actually fixed things when you fired it up. You're still crackly. Yeah, you're still crackly right now.
Yeah. Let's see if there's anything else I can do with this. Does that make any difference?
Yes, it did.
Really? So all I did there was I just changed I just set this settings mic. Really, that made it better?
So what are you doing? Just toggling this thing on and off?
Yeah, can you? I don't know if you can see this, but yeah, look at that. Woo! Look at that. Look down the hallway. So right here, I have this little settings button, and then this was set like this. If I do that, then my voice goes bad, I think. If I do this, then my voice is okay.
Yep.
Huh. But I've already done that once. This is actually the second time that I set it, so somehow it became unset.
Windows.
I think this is really more of a Google web thing, Hangout thing. But anyway. All right. What a shame. All right. Well, the first time we've done this, so it's bound to be a little messy. Okay. onwards and upwards. So we've created this new CPP file. We've gone through the enter function and pretty much left it unchanged from regular RTL. So next we need to, we would need to update this update function, which is going to get called 50 times per second. I'm just going to leave it as it is for the moment, because we just want to make sure that first we get the basics of SmartRTL working. So we're just going to leave that as it is. And we're going to have a quick peek at our web page, which describes the steps we need to go through. So how far do we get in this thing? Right. Right, okay, so we got this far where we created the CPP file. Then next we actually have to instantiate the class in rover.h. So coming down here, we can just look for mode RTL, I guess. Mode RTL, there it is. We can add our new class in here. Mode, and now here, do we do it underscore or not? Seems we're not using our underscore this time. All right, so we've added that. Done 4. So now inside of control mode for num, we need to create a mapping between the mode's number and the class. So this is again in rover.h. Right here. Here. Yeah, here. Must be in. Here we are. Got a little bug in the explanation there, so I'll have to fix that. So here we need to add our SmartRTL. So that's the link between the number and the object. So that has been added now. And then so that was 5. All right, okay, and then we need to go in, add it into the parameters list, into the mode 1 parameters value. This is just the description, the parameter description here. We need to add the new mode in there so that the ground stations are aware of this new mode. So we'll go into parameters.cpp, look for mode 1, like this. Here, and I think we made it 12, right? So this would be smart. Once this, yep.
Can you poke your audio again, please?
Really got funny, has it? Nope, still looks. This time it looks okay. Hello. Any better?
Yep. It's good again.
Strange, very strange. Okay, so then we add this SmartRTL into the mode parameter descriptions. So once this whole big change gets pushed into master, then the various ground stations will be able to parse these parameter descriptions, and they will become aware that there's this new mode there. So until this is committed to master, when you open up your ground stations, you won't see the flight mode in your list of available flight modes, but you can still actually go in, into the parameters list and modify the value for mode 1 to make it 12, and that way when you switch the flight mode switch to say position 1, it will actually switch the vehicle into this new flight mode. So even though the ground stations aren't aware of this new mode, you can still test it yourself on a real vehicle by manually updating the parameter value. Okay, so we've done that now. We've done 6, and that is it. So that is the skeleton. So We'll just make sure that compiles. And maybe over here as well to make this commit visible to people who are not using my computer. People like Peter might actually commit this change. So I use source tree, by the way. It's a Windows only tool, but it's a bit like Git Kraken, I think. If you're on Ubuntu, you might use Git Kraken, so it's a bit similar to that. So let's do our commits. They always start with the name of the vehicle or the library. So it's Rover in this case, and I'm just going to add skeleton SmartRTL code like that. And made a mistake somewhere. Okay, so this looks like just some kind of regular build error, and I'm going to do a clean. I just did a full clean, unfortunately, though. So that means it's going to be building for some time. Building is much faster on Ubuntu, by the way, than compared to Windows. So if you can use Ubuntu, you should. While that's doing that, I'm just going to commit this. I'm going to push it up into the branch. So it's a new branch, just push it there. And I'll start this guy compiling again. V2 and V3. V2 is for the older Pixhawk ones with the 1 megabyte limit, and this is for the new Pixhawks, and including the Pixhawk 2, aka the Cube. So we do have a flight mode now. We could test it and make sure that it actually works, but maybe not. Maybe we'll just move straight on to the next step, which is modifying SmartRTL so that it actually works for us. This is a much bigger job. Okay. So the first thing we need to do is probably get this SmartRTL library actually building inside of the Rover codebase. So the way that SmartRTL was written for Copter is it was written in two parts. There is the flight mode part, which you can see here. Control SmartRTL. This is that thing which is quite similar to Rover. It's a set of functions instead of a class, but it's still conceptually quite similar. It's got the initialization and stuff in the run. So there's this part of it, but this is actually the simple part. The complex part is all down in the libraries area. So if you look for the libraries directory, AP SmartRTL, this is where all the smarts are. And this library provides a bunch of methods like, is it active? Are you actually, is it usable? But some of the key ones is the pop point, which you use when you're returning home, and also this update function. So this update function needs to be called 3 hertz or higher, and it will store the vehicle's position in a little, not a little list, but in a list. So basically we need to get this SmartRTL class instantiated as an object inside of the Rover code, and then we need to probably call the init as part of the overall Rover initialization, and then we need to call this at 3 hertz to store the vehicle's position, and then when SmartRTL rather is when the user switches into SmartRTL and that update function runs, we need to start running this pop point and then feed this into our navigation controllers. So that's the next step. So maybe we'll wire it in first. There's definitely an underlying issue inside of SmartRTL which we're going to have to handle, which is that SmartRTL currently works in 3D. Whereas for Rover, we're going to need to work in 2D.
It might be that we can just feed in 2D waypoints in SmartRTL.
That's a good idea. It doesn't currently, it does actually. If we use this one, this version of update, we can actually, yes, you're right, we can actually manually pass in our position instead of it getting the position itself directly from the HRS. Okay, alrighty, let's move on. Okay, so let's get this object inside of Rover. So what I'm going to do is I'm going to just see what we've got here. Now, there was actually, I think Peter provided a link earlier, which I'm going to close now. There was actually a commit that went into Copter to add SmartRTL, and that sort of shows us quite a few of the things we need to do. But maybe I'm going to ignore that for now, and I'm just going to try and wing it. All right, so certainly we're going to need to include the library. That's obvious. So right in here, right at the top of rover.h, we're going to include this library. Where should we put it? Maybe in here. We're also going to need to create the object. It's calling it smart. I'm looking at the Copter code here, right? So this is the SmartRTL state. This is different. This is something else instead. Probably going to need that too, though. What is that? What is the state? Let's assume we're going to need that. It's going to be private. I guess it'll be private. Put it down here somewhere. Where should we put it? Doesn't really matter too much. So I think I'll put it right here. Okay. SmartRTL init function. That's for the flight mode class. I'm surprised there isn't a SmartRTL class. Where is this? Where's this thing? Yes, of course. It's created as it's got parameters. So it's going to be an object with parameters in the G2 object, probably. Okay, so
And your audio's gone again.
Oh, is it? Okay. Don't worry, we know how to fix it now. How's that?
All good.
What a mess. Oh well. We'll try and get it better for next time. Okay, so what we need to do is we need to add this SmartRTL object inside of our G2 object list, parameter list. So this is very similar between Copter and Rover. So I'm just going to grab this and we're going to put it down here. So there's a G2 area. Okay, I'm attempting to be back. I think I'm back. Hello. So let's stop looking at me and start looking at the screen. Sorry, my Windows machine crashed.
I've been pretty payroll for the last couple of weeks.
Yeah. Alrighty. Well, we're plagued with lots of technical difficulties, but we're going to keep on trying.
Working on live streaming some Rover pair for them. Peter, if you're interested.
Oops, we had our mumble chat was coming through. All right, so everybody can hopefully see my screen again. Right. All right, where were we? So what we were trying to do before my machine crashed is we were trying to get the SmartRTL object. Sorry, I'm just a little distracted. They're trying to get the SmartRTL object building within the Rover code. So perhaps I didn't explain it completely, but there are when you want to create a new instance of an object, there are basically two ways to do it. If it's a simple object, just like a float or something like that, you can just create it inside of rover.h. So if you have your new float, you can put the new global float, my new float. You can do it like this, and then it'll be visible all over the code base. But if the object has parameters, then you need to link it into the Rover's parameter tree, basically. So SmartRTL does have parameters, so that's why we need to do it. It's not the simple method; it's slightly more complex. On the wiki, we actually have a page which talks about adding parameters and stuff. So in any case, okay, so we need to. What we're going to do is basically just copy it over from Copter. So the SmartRTL object is, you'll find a little bit of it here. So we've got this little thing, this little definition here, declaration, in parameters.h. So we'll need that for sure in Rover. So just come over here to Rover, to parameters.h in Rover. And by the way, we also, inside of our parameter tree, we have two different sections for parameters. We have the regular one, which you'll see, referred in the code bases starting with G, so like G dot or G period, and then like the name of the parameter. So we have that, but then we got so many parameters that eventually we had to create a new section. So we now have a G2. So from now on, actually not from now on, from about a year ago or so, we've been putting all of our new parameters into the G2 parameter list. So that's here. So right on the bottom of this, I'm going to add the SmartRTL object there. And of course, you also need to add into the CPP part as well. So just go back to the copter parameters.cpp. Look for our SmartRTL object. Here it is here. Grab little, parameter descriptions and stuff above. Grab that as well. Come back in here. Just jump around a bit. Go right down to the bottom where our G2 list. The bottom of our G2 list right here. There we go. There we go. Yes. Of course, this number has to be updated. And that looks pretty good to me. Now you've got the name of the class. You've got the all the parameter names that come with the SmartRTL library. We'll start with SRTL. You've got the name of the object there. That looks pretty good to me. I think I'll get rid of this copter one now. Get rid of the copter parameters. All right. So now my feeling is that we should have we should have a working SmartRTL object now. So for example, if we wanted to use it in here, we should be able to do something like g SmartRTL dot init or something like that, and that would compile. Looks like Eclipse is happy with it anyway. I'm going to kick off a build just to uncover any compile errors, or typos, whatever that might have slipped in.
There's currently a compile error in mode.h on line 333. You're missing an underscore in SmartRTL.
Really? Okay. Sorry, where was it? 333, you said?
Yeah, it should be.
There we are. Thank you very much. This is going to take forever to build, though. So we should just keep moving on. Get rid of that.
All right. The second compilation failure you'll get is that Rover's home is set variable is private within the scope. I think what that means is that you want to make SmartRTL a friend class for Rover.
I see, okay. The home is set is part of the RTL object. That seems strange, but okay. So, right, so we're gonna allow okay. All right, so now we're getting some comments that people can't see the IDE, but it seems to be affecting only some people. All right. Okay, some can see it, some can't. All right. Sorry, Peter, you want to just tell me again what you think I need to fix here? I think I need to add.
Okay, at the moment, in the top of rover.h, you'll find friend class, mode acro, mode auto, mode guided, mode hold, mode steering, mode manual, mode RTL.
Ah, yes.
Pattern here.
Of course. Yeah. So SmartRTL needs to be added up here.
Yeah, I think it would be reasonable to add an accessor onto the rover object to avoid having to friend all these things.
Yeah. Or I should add this to the wiki page later to make it clear that this is one of the steps you need to go through. Okay. And after those two, it builds, I guess. Alrighty. So, okay. Okay, another thing we should that we'll need to do to get the SmartRTL thing building is to actually add it to the build file. So we have two different ways of building things in ArduPilot. We have the old method, which uses the make file. So I'm just going to we're just going to open up the make.inc file. Rover, APM Rover.2, sorry, APM Rover2 directory, make.inc. And then right at the bottom here, we need to add a new library. SmartRTL, all one word like that, maybe. Okay. So we added there, and then the other file that we need to modify is the wscript file. So we need to add it here as well. Okay. Just make sure we got those names right. AP SmartRTL. Looks correct. Okay. So that we've added it there, so now it's added to the build. Hopefully there's no further dependencies we need to add. All right. Next, what do you think? Should we try initializing the SmartRTL object as part of the Rover initialization?
As always, I think with this, see what Copter does and do
Yeah. Okay, so we could have a look. We could have
Except Copter doesn't have flight mode and stuff.
what we could do though is we could look through Copter for SmartRTL dot.
Your audio's just gone bung again.
Oh, is it? Okay, let's fix it. There, how's that? Better? Better?
Yep, all good again.
Yeah, cool. All right, so I've just done a global search here for every place where SmartRTL appeared in Copter. And we have a couple of things. So inside of this is the initialization. So when an ArduPilot or in this case Copter first starts up, it does all this initialization of all these objects. This is the init ArduPilot function. So it initializes all kinds of things, battery monitors and all kinds of stuff. Part of that is initializing the SmartRTL. So we're definitely going to need that. So in Rover, is it called the same thing? If it was, this is in the systems.cpp. Let's just see if we've got the same thing. We've got an init ArduPilot, and there we do. Great. So let's just, yeah, this looks good. Serial managers, relays, cameras, somewhere around here, I think, feels like the right place to do it. Here we go. Right. What else we got? This is the Copter SmartRTL flight mode. So we're going to leave that alone for a bit. What do we got here in motors? So in the motors class, we got init arm motors. So when the when Copter arms, it calls this reset path. And I think really what this is doing, this is recording a home location inside of the SmartRTL library. So of course the vehicle has a home location. For whatever reason, the SmartRTL library has a different, it has its own copy of the home location. There's actually some good reasons for that. Maybe I won't get into them all, but to put it simply, in the vehicle's home, well, in Copter you can move the home position around using Mavlink messages. SmartRTL does not support at the moment, at least, moving home positions around, and it's quite a difficult thing to support because you can imagine you're recording a path, and then the user comes in and moves the home position 200 meters, off the path. So it would be difficult for SmartRTL to ever know how it could possibly get to that position. Maybe there's some complex way that it could do it, but we don't support that for now. So that's why it has to maintain its own copy of the home location instead of using the vehicle's home location. So anyway, what we need to do is when Rover arms, we also need to record this, record the position, current position as the SmartRTL home. So where is arming in Rover? Where is arming? It's not called init arm motors, I don't think. Where's it going to be? Is it in radio, maybe? This is where it checks whether the pilot is arming. We've got a disarm motors call. Oh, there it is. There's an arm motors call. Let's find that. Oh, it's in system as well, probably. There it is. Okay, so right here, let's now, okay, this reset path takes an argument, and the argument is whether or not, so you can give it a location, right? The true or false, I think, is basically to say, do we have a good position at the moment? So because if you don't have a position when you arm, SmartRTL becomes deactivated. So you basically tell it as part of this whether or not you've got a good position or not. Now, Rover only supports arming when you've got a good position, so we can just always set that to true. I could just do this. I also see though that it's got a second version of this function, which allows you to pass in a position. So that would be what we would want to do when we, to make the SmartRTL always work in 2D instead of 3. Let's just jump over that for a second. So we've got our reset path here.
On that 2D, 3D thing, people have pointed out that retaining the 3D nature, even for Rover, is going to be a good idea for things like bridges.
Yes, indeed. I thought about this as well. So you can imagine, going through like, going through like, one of those spaghetti intersections they have in the States, where roads cross over each other a million times. The thing that I worry about is barometer drift. So if you get, you can definitely get barometer drift of a couple of meters, and so therefore, even though the vehicle might be on the same road in the same place as it was previously, it looks like it's a couple meters off. And so, I mean, that's not the end of the world. It just means that it won't shorten the path when it might, when it could. So yeah, okay.
There's also been the prospect of cliffs.
Yeah. Okay. Yeah. Good point. I mean, I guess worst case, we just end up not clipping. Not pruning when we could. That's the worst case scenario. So it might end up being round.
The worst case scenario for ignoring height altogether is you drive off cliffs.
Right. Yes. Yeah. Okay. All right. So let's leave it in then. That sounds good. It's easier as well. So easier to leave it in. Great. So we've added the init. So the object should be initialized now. So we're racing forward. What else we got? We just did that. We did the init. Sorry, we did the reset path as well. So now we're actually down to what we need to do inside of the object itself, the flight mode object itself. That can't be true. There must be an update function as well. Here we are. Yes. So in Copter, we have this SmartRTL save position function, and this is where it is recording the vehicle's position all the time. And it only does that when you're not in SmartRTL. So we need this. We need this kind of function in Rover. Inside of Rover. You guys can still hear me okay?
Yep, audio still good.
Great. All right, so here's the question, Peter. Should we put this save position, should we jam that into the RTL class itself? If that makes sense, right? It wouldn't, because we could make it as a completely separate function out inside the vehicle class, but it probably makes more sense to put it inside of this SmartRTL.
Yeah, it does. In fact, I've been using on actually putting the SmartRTL directly within the mode. It would require more hooks into the modes than we currently have, because it would have to have a periodic update function, for example. So not worth doing this for this loop, and we'll keep it more like Copter.
But we could have a little function though right here, though, right? Which is a little state position function like this, right? But it just gets called from the code.
Yeah, your audio is just gone, but I do agree with what you're saying.
Is that better? Am I back?
Yep, you're back.
Yeah. So of course you can't call this from the scheduler, really.
Sorry, hang on. Your audio is still bad. Sorry.
How's that? Any better?
Yep, that's better.
Any better? If I click here, still better? Still okay? Still hear me?
Yes, I can, and it's all good.
Okay, great. So, okay. So, I mean, we can have this little function here inside of the SmartRTL drive mode class. But this thing actually needs to know what the, one of the important things that it needs to know is whether or not it's in the SmartRTL mode or not right now. Which it could do. I mean, it could internally figure that out. It knows what it can call it. Really? Okay. Terrible. Huh. Seems to be getting less reliable.
Yeah, put it again now though.
Weird. I wonder if I should drop out of Skype again. Probably doesn't help. Maybe. Just because it can't hurt, I'm going to try and drop out of some of these other things. Still here? Still hear me okay?
Yes, it's all good.
So what do you think? We need to basically turn on and off the saving of the position based on our control mode. So, basically just based upon whether or not we're in SmartRTL or not. So if we're already in SmartRTL, we don't want to be doing this. So the SmartRTL object knows, or it could know, whether it's active. So I guess we could move this little tiny bit of logic into this little function inside of SmartRTL. Do you think that's a good way to do it?
Yeah, I was just you could have like an isActive thing here.
Yeah. We're still going to need to have a little, another function in the vehicle class, though, right? Which calls this function, I think, won't we?
Yeah, but that's actually one of the reasons the object, you actually have a handle on each of the objects in on the Rover. So it's not just an array, it's like, mode, save SmartRTL. So you can actually kind of call these functions.
Yeah.
Now,
okay. So if we wanted to add let's just go to the scheduler. Is that in APM Rover or is that in Rover? It's an APM Rover. So here's our scheduler here. So we need to, this is where we need to basically call this function which stores the vehicle position at 3 Hertz. So we're going to need to add something in here, a line in here. Somewhere it's sort of important. So these are in priority list, of course. Sorry, priority order. So is it more important than notifying? Probably. Is it more important than accumulating for your compass? Perhaps not. Fail safe. So let's. I think it feels to me like it should go right about here. So I think we're going to add a new task in our scheduler, which is going to be called SmartRTL. What do we want to call it? Is it store? Is it reset path? If there isn't, it is update. It's a little confusing for people as to whether that means class or the object, but let's call it SmartRTL update. We can't do something like this though, right, Peter? We can't do mode SmartRTL dot we can't put a function in there, right? It's got to be no. I think it's got to be we just have it like that. You don't want to call it 50 times a second. We want to call it 3 times per second. So we need to write this SmartRTL update function anyway inside the vehicle class. So we'll create a new one of these. Going back to rover.h, we're going to define this function. So there's all of our objects. So I'm just trying to find a good place for it. Those are includes our objects. So where do we keep going down? Hopefully we'll get to a list of functions. Here we go. Right. Right, so where are we going to put it? Commands. There's a lot of homey-like stuff in here. Feels to me like this is a decent place to put this function. See if there's any other places we could put it, which makes more sense. Events, GCS stuff, logging, radio, sensors. It's not really a sensor, but it's kind of close. You have an opinion about this, Peter, about where we could put it? You put in system as well. System also makes a lot of sense. Maybe system.
Well, yeah, I noticed you got steering up there, which is also it's that maybe a separate mode specific section.
You mean like create a new file?
I was thinking just a new section in there. That's all.
Yeah, I've actually got these organized by CPP file, so you can see all of the functions that are in each CPP file. So can't really create a new section without creating a new file. I think this is very home-like, so this command makes a lot of sense, but I think I'm just going to go with the default of putting it in system instead. And I'm going to put it right below update notify. And of course, we have two different, sometimes we put the verb at the front, and sometimes we put it at the end. In this case, I'm gonna put the verb at the end, so it's SmartRTL update instead of update SmartRTL. Okay, maybe I'm obsessing over something that's not that important. All right, into system. Okay, systems.cpp. So I'll go right down to the bottom here. Except we should use our Rover system.cpp, not the copter one. Here we go. So right down here, we'll add a new function. Something like this. Store position for using SmartRTL. Okay. This is the Docker version of this function. I want something very similar. So we want to make sure. I think we might move. I think we're thinking that we're going to move this stuff, right? What we're going to do. Let's just move all the logic into this function inside of SmartRTL mode. So what is it? Smart. I forgot what the mode is called. We're just going to call this, right? Store position, is that what we call it? We call it store position. Save position. So I think we're just gonna keep it simple like that. Put all the logic in one place instead of having it scattered about. All right, so we got this function now. So now inside of SmartRTL, we need to add this save position method. So put it down at the bottom here. Okay. Now, this is here we're actually going to know that our position is going to be okay, I think. Let's just do this. We're going to assume that our position is always okay. And
Wasn't save position just called by the scheduler?
Sorry, what's that? Oops, sorry, couldn't quite hear you there, Peter.
Sorry, the save position function was just called by something called from the scheduler, so you can't assume your mode is correct.
That is true. Yes, that is true. Yes, we've taken all of them. So we
put
need
something in there.
You think we should just stick something in here? Because we could stick it here. We could stick a little bit of logic here, or we could make this guy aware of whether he's being updated or not. Because we do have this enter and exit, so we could store a little Boolean somewhere as to whether we're active or not, and then do it. Do you think that's just a little too complicated?
Yeah, I'm not sure they really should know that. I mean, anyway,
Yeah.
I mean, I'd do it as like an active callback or something like that.
Yeah. Okay. Yeah. Okay. All right. Fine. All right. So we'll move the logic up here. So we'll take it out here. So this doesn't do anything then, really. And so this guy will need a Boolean, right? Save position. And so he'll call back, right? I don't actually think the update function does anything when you ask it not to save position. But all right, let's put this back here. There we go. So, all right. So is the vehicle armed or not? Is the vehicle armed? What is the method that we use in Rover to say whether or not we're armed? It's probably like arming.armed or something like that.
I think the way I've found to do that is you just look at the soft armed flag, so get soft armed.
Okay. So, it's something like this, right? Sorry, I'm still getting used to Rover, so I slightly forget how we check.
Thank you. Hal get soft armed, I think.
Okay. Yep, there it is there. There we are. Okay, so back, not here, but here down at the bottom. I guess this is just a true or false, I hope. Yes, it is. And control mode, there we go, does not equal. Now this is not right, it's not like this, it's like this. Maybe. There we go. Okay. That's fine. We had some junk there before when it was compiling, so it bumped into that. All right, so I think now we have a we now have the SmartRTL object created, and it is being called intermittently to save positions. So this seems worthy of another commit. That'll allow Peter to have a look at this code as well while we're doing it. And maybe I will just fix those little issues that you found as well. Right, here we go. That one. And there was another one, right? Where was that other issue that you found? I guess this friend class, that had to be there too. All right, so fix, there we go, so over, add skeleton, SmartRTL. And now we are going to add another one, Rover, add SmartRTL library to build. And then here we are going to add this, and Rover is going to be what? Integrate SmartRTL library. There we go. Cool, we're going to push all that up. Okay, let's move that out of the way. And so something didn't build for some reason. SmartRTL state does not name a type, right? So, right, yes. So, just for a moment, I think that this SmartRTL state was something that we added into Copter. Yes, I know what this is. We don't need this. We don't need this. In Copter, the RTL is quite complex, so you know, relatively complex anyway. So it does things like the vehicle stops. Yeah, it has to perform a stop, and then it starts coming home, and then when it reaches home, it starts doing a land. So there's various states that it needs to go through. And Rover's much simpler because obviously we don't have those you know, landing states. So I think we don't need that little bit. So I'm just going to.
Might be worth just adding it as an empty structure, or you know, some trivial structure. I'm sure stuff will go in there at some stage.
You think so? Yeah, maybe so. Maybe I'm going to just chop it out for now, though. So I'm just going to. I'll just keep it compiling. You don't like that decision? Fair enough. I don't know if we're going to need it.
Yeah, I'm just looking at the enumeration now, and you've got wait for path cleanup, which might be important for rovers, for example.
Oh, shoot, I think you're right, actually. Yeah. Yes, you need to. Yes, you do need to wait for the path cleanup. Anyway, let's see. Let's see. I'll put it here. It's commented out. Let's just see what we have to do. Okay. So now the tough bit, right? Here's the tough bit. We need to actually make this darn mode work. Get rid of some of these other files that are just not important. Get rid of this stuff. Okay, so should we have a look at the Copter again? See what Copter does?
See the bumper sticker now. What would Copter do?
Another mistake here. We need a SmartRTL, some kind of SmartRTL definition. Okay, so we're missing something here. SmartRTL, that's what the library is called, right? Yeah, there's the object there. Let's see if when we instantiate that, if we have to pass in any arguments. Oh, that's Rover. We're back in Rover. Aha. You have to pass in an HRS object. That's not too hard. The parameters G2 constructor. We have to add our new guy here, and like that. Hopefully. get it compiling again.
Yeah, I think you also need, for example, mode. So false, I guess.
Sorry, example mode?
Yeah, the constructor takes a second argument. So it takes the HRS reference and a Boolean for example mode.
Example mode. What is that? Oh, right. Right. Does that not default to false?
I think that would be a reasonable patch to make in there. Just patch
like
SmartRTL to say equals false.
Yeah. Yeah, that's. Oh, it is. Look, there it is. Yeah, so this is just as a side point for those watching. In order to test the SmartRTL object, we have a little separate testing class, sketch, whatever you want to call it, and so that's what example mode means. It means it's used for testing. So it has to. It does very small changes to the initialization to allow it to be tested properly. So anyway, looks like we just. That's what that second argument of the constructor is, but it defaults to false, so that should be good. If we're lucky, we'll get this thing building now. Here it goes. There it is. Oh, it didn't make it. Damn. Save position shadows a member of this.
Add underscore still stop screaming.
Underscore?
Yeah, just underscore on the parameter name. Just pass it through.
Oh, right. Yeah, the name of the function and the name of the variable are the same, right? I guess that's what it's not happy about. Something like that. It's a bit questionable, isn't it? Was there another part to it? Is there another? I renamed another thing which is the same. Let's have a look at mode.h. Make sure that. Zero. Okay. We've been going for about an hour and a half now. Getting there.
Might need some sort of a montage in the final video.
Yeah. Yeah, it might be. Might need some editing. Hey, it got through it this time. Okay, so let's just commit up those few fixes here. Not too exciting, but one little issue with this version of a source tree is that it gets unhappy if somebody else is modifying the file system at the same time. Sometimes it won't let me actually do the commit because this guy is upsetting it. So. Okay, so all right, now the very last part, I think, is this. So we need to actually make this guy use the SmartRTL object to get home. So this is not correct. Let's get rid of that. So this is the equivalent on the copter side. So does the init? Yeah, that's just is where it sets that little state to wait for path cleanup, right? And then so during this state, the copter just stops and waits. And during this wait, while it's waiting, the SmartRTL object is doing processing in the background. It's going through all the points in the background and doing simplification of the path first to remove any extra points, and then it does a pruning where it cuts out loops. So this that will need to be done, I think. And then this is where it actually drives back. This is where it drives back, and this is where it lands. So we don't care about this. I think we just have two states, it looks like. We still have the wait for cleanup, and then we have this guy. So, right, so we need to call this. Yeah, we need to add something like this. And then we need to get ourselves home. So we need to do something like this. Excuse me. So what are we going to do in Rover? I don't think we need a full. First of all, that state should really be in the mode itself, I think, not in the vehicle class. And I think we just have two versions. Sorry, two states really. So I don't think we need to have. We just have a Boolean. I think will work. So there, Peter?
Yes, I'm still here.
Cool. All right. So in here.
You know you're going to put that stuff in a structure at some stage. Just saying.
I think so, eh? I don't know. Not convinced. I'm gonna take. I don't think we're gonna need this. Should be there anyway. We got this guy here. I think it's really quite simple. So when we enter, we don't want this. I think what we're going to do is we're going to want to stop the vehicle. I think we should stop the vehicle here. And we're going to, sorry, this belongs down here. We can use this somehow. So we're going to stop the vehicle, I think. Right? The other thing that we need actually is we need to make sure that we have a position, right? Just like we do in other modes like steering. How come RTL doesn't have that actually? Because if home is not set, you couldn't possibly have a position. Is that the idea? What we probably need to do, I think that the SmartRTL has an active thing. So instead of doing this, we should actually check if it's active. I bet you will find that in the copter one.
Bear in mind the flight modes conversion for copter also converts the SmartRTL flight mode, so some hints might be taken from there.
Here we go, this thing. This thing. So SmartRTL will only be active if it was able to store its position right, at the moment that it was the vehicle was armed. So I think we don't want this. We want this. Not active, return false. So we just refuse to enter SmartRTL if SmartRTL's home has not been set. Okay, so there we go. Okay. Now, I think we're going to stop the vehicle. The first thing we're going to do is stop the vehicle, which, maybe we won't get to a stop. If SmartRTL can sort of, prune everything really quickly, then there won't be much of a delay. But I think we should initially start slowing down the vehicle, which is what stop vehicle will do.
Does that stop vehicle function require position?
It does, but we should have a position, because if we didn't have a position, then this would never have been true. I feel. I think in Rover, you have a position or you don't have a position. It's like I'm not sure I'm not sure exactly how we handle the situation of, say, for example, the EKF losing its position estimate. That would be a case, where we had a position at the beginning, but then we lost it in between. And we should really be checking that and then not allowing ourselves to enter RTL if we don't have a good position estimate. But I don't see that even RTL is doing that. So maybe we've got a loophole there, or maybe the failsafe kicks in and just stops the vehicle if we lose our position anyway. So maybe the failsafe is keeping us safe. I'm thinking that's a bigger issue than us adding the SmartRTL mode, so we can just put that aside for now. Okay, and then we need to set that new variable, this one here, this waiting for cleanup, to be true. Oops, it's not related. Init, state, how do I? Non-comment, really. Okay, initialize that. Then inside of the update, okay, so if something like this, I think, waiting for cleanup, and then waiting for cleanup equals or we can make it cleanup complete.
Need to change the value. Cleanup complete is false initially.
Thank you. Okay, there we go. So now, so this should just keep on zipping back and back, back all the time. Maybe we should keep doing this.
Well, updates called repeatedly.
Stop vehicle surely needs to, keep slowing the vehicle down. So we need to, we don't really need to have this here actually, right? It's going to get called. It's going to get called back down here, so we don't need it up there. We can do it up here.
As set reverse there is.
That's true. This could be here or it could be down here. We're never going to reverse an RTL. It could be there or here. I'll just leave it up there for now, but it could come down here. This one, you know, theoretically, we should actually do this, right? You know, this would stop even one iteration from trying to stop the vehicle. I don't know if it's really important, though. What do you think? It's going to try and slow down for a moment.
Yep, you'll still need an early exit, I think, based on whether you actually, yeah.
Ah, good point. Yes. So
Return.
we could just always early exit once. Technically, it's one iteration, right? It's 20 milliseconds, where potentially we're losing 20 milliseconds. But you know, this cleanup is always. I'm pretty sure this cleanup is never going to. The first time through, it's going to need a little bit of time always anyway to clean up. So I don't think the vehicle is going to, you know, jitter or stall any more than it would than if we had another check here. I think this is going to be.
Just put a comment in saying that we might just lose a loop, but who cares?
Yeah. Okay. Okay, there we go. Okay, so if we've gotten past this, then we know that we are actually trying to get home. The cleanup has happened, and we are trying to get home. So we now need to feed. You're right. We may need that structure. We may need that structure. We need to. So what do we need to do here? We need to pop points out of safe RTL, SmartRTL rather. Feed them into the SmartRTL class. Sorry, feed them into the navigation class. We need to feed them into the navigation class. Then we need to check we've gotten home. Okay. SmartRTL will actually tell us if when we're popping points out of SmartRTL, it'll tell us if it's the last point or not, i.e., is it home or not. So that's how we're going to know whether we're on the last point, whether we're heading towards the last point or whether we're heading towards an intermediate point. Alrighty. Surely this reach destination needs to be set as well. Yes. Okay, so okay, well, let's. Any comments? Welcome if you got any there, Peter. Go back here and see how we pop points. So this is the copter codes in SmartRTL Run. This is where it's popping the points. So let's grab this. Let's grab this whole thing. assume that somehow we've already got a point. We've already received a point, but we haven't reached it yet. This is the opposite. We've reached the point. Yeah, okay, so if we've reached a point, then we need to get another point. Yes, and this is how you determine whether it's the very last point or not. Yeah, this is where we do record the state, isn't it? So this is where Peter's words of wisdom are going to come true, I think. Yeah, so we do need a bunch of things, right? We need a bunch of states. We need a state which is going to be, we need to have a state like, you know, like starting out or initializing or something like that. You know, like this is where we need to, you know, get the first point. Let's see how. And then we're going to be returning. And then it's going to be like probably one of the last point. Okay. An origin and a destination. So actually, it looks like, right, we're going to need a little bit different than Copter, where the origin and destination are stored inside the navigation library. So you just give it a destination, and it records, you know, where it used to be going. You know, it records the origin and the destination. You know, even if you just provide a destination. For Rover, we actually need to maintain an origin and a destination. So, so as we pop points off, we're going to need to actually move the previous point into the origin, I think. Yeah, okay. I need a little break, actually. But, okay, just handling the very simple case at the top here where we've somehow already managed to, you know, load a point into our origin, our destination, and we're just still continuing to drive towards it. So these are the things that we need to do. We've got this desired speed as well. It needs to be set somehow. So we need to set this somehow. Yeah, it's fairly simple, I think. Let's do the simple thing first. Let's see how the regular RTL sets the desired speed. where's the target speed being set? Here we are, right here. So when you call the set desired location, it sets all that for you, defaults it to the cruise speed or speed cruise parameter. So this is doing quite a few things for us. Sets the origin, the destination. We're going to call this though anyway. We're going to call this. I think we're going to end up calling this a whole bunch of times inside of our, right here after we load up the point, we're going to end up calling that set desired, whatever it is, set desired destination. Set desired location. I think we're going to end up calling this a whole bunch of times. So that desired speed is not a problem. I think I might take a little 5-minute break. We've been going at this for 2 hours, so I think I might, take a little break. So I will be back in 5 minutes. Sound good?
Yep, time for a cup of tea.
Yep, sounds good. So maybe I'll write a little note here. There we go. All right, I will mute myself and I'll be back in 10 minutes. Hey, Peter, you there?
Yes, I'm here.
Cool. All right. So yeah, I'm definitely getting a little tired, but okay. So I'm thinking, yes, you're definitely right about this whole state thing. So I definitely think we need that state. So this cleanup complete should be extended into a state, I think. What was our state called? Called the same thing.
SmartRTL. It's in Copter's, of course.
Here. SmartRTL state. Let's grab that and move that over to here. The nice thing about our having all the classes and all the modes and classes is that we can put these, you can hide these states, etc., within the class itself instead of having it as a global state or global enum anyway. So, okay, so we need this. Okay, so we can have this wait for path cleanup. So that's going to be 1. Path follow. That's going to be our driving home. We probably don't need this pre-land position. We probably do need something like a stop at home. You think sound reasonable?
Yep, perfect.
And we call the actual, what did we call the actual? This, right? So here, we will initialize. Where did it go? I've lost it. Okay. So instead of this, we'll have this. So do this.
I think you can reach destination there as well.
Remove this, you think?
I think that just becomes a state.
I wonder. Problem is, this is also going to go true and false as we reach each intermediate point. But maybe you're right. Maybe you're right. Actually, you're right. This reach destination should probably be shouldn't go true. You're right. Sorry. Actually, this reach destination shouldn't go true and false as we reach each intermediate point. This is meant for the final destination. So you're right. This that needs to be changed. In fact, we've got this reach destination here, and this should probably be this, right? Like that, maybe? Anyway, right?
Yep.
Okay, so here. You think a big switch statement, maybe?
Yeah, certainly the structure in Copter for the equivalent function.
Sorry, I didn't quite hear that, but this thing here.
Yeah, that's right.
Yeah. Yeah, we got something very similar here. I guess they've got different functions, so we can decide whether we want it to just mash it all into one big function, or have a bunch of, just do it all in one place or not. I'm not sure.
Yeah, Rover's usually a lot less complicated than Copter, so it might not be worth breaking out the functions, but it only has to get a little bit dirty and it's worth doing.
Yeah. Other options that we need to take care of. Like that. So, there's a way to want this stuff now. Okay, cleanup complete. So if true, we need to move on. So it's kind of like this. And move on to the next state. Something like this. Okay. In here, so here, there's a question about whether we need another state in here, which is sort of like load next point from SmartRTL object. Do we need that kind of state? So here you move into the load, and then after it's loaded, we move on to the state, which is sort of like follow, and you just
You just bounce between those two states, and isn't the load immediate anyway? You don't need to wait.
You don't. Yeah, I'm not sure if we actually need that other state or not. We need to do this somewhere, right? We need to do. Oh. Okay, so we need this. Some of this anyway. We need to load. What do you think? Think we should have a new state for the load? I mean, we could have the new state for the load and then have it fall through to this. That would be another way to do it.
You could. I just do it all in the path follow to start off with.
So, yeah. Okay, and this worries me now as well. This is the Copter one, but it looks like in Copter we support navigation using a 3D vector from the EKF origin. That's what this is, right? And in Rover we don't support that yet, so we're probably gonna have to write a little conversion function, which allows you to specify a destination not as a lat long, but as a offset from the EKF origin. Anyway. A little bit. I mean, we never thought that adding this mode was going to be that easy. But okay, so we need to know. We need to know now if we already have a point loaded or not. So we could load a point here. It's one thing that we could do. But I don't really want to do that. I want to do it here, don't we? We just need to know if we've reached the destination or not. We could add another. We have a point. I think we need another. I think we need another variable, right? Either a variable or a state. I'm going to do this way for now. We'll see what happens. Okay, so we pop the point off. Okay, if we can't pop a point off, then clearly there are no more points. And so we just need to move on to the next state, I think. It's just time to stop the vehicle. We've basically reached home. Otherwise,
I'd probably just put a brake in rather than doing anything else. You're never going to want to do anything else in here.
okay. Got a point, and now we need this. We basically need this. Sadly, it's in the wrong format. This. Work. Need that. Okay, so we'll come back and fix that in a minute. Then we need to just do this stuff, I think. Yeah, okay, yeah, we're gonna need all this stuff, I think. This is our standard kind of navigation towards the point. Right, so we're hoping that this function here will have set our origin and destination. So we need to update this kind of globe, this variable here, so that we can report to the ground station how far we are to the next point. Actually, this is maybe not what we want. We probably really want this to be home, the RTL home. We'll leave it like that for now. So then we're going to keep steering towards from the origin to the destination using our L1 controller, and we're going to Also update our throttle to try and drive towards the next point at this desired speed, which was set from this. So that will move us along. But here, you know, we do need to know our distance to the next point, because we need to do this. We need to check if we reach the next point. Just so this is going to be a we can just do this. We can just grab this here, I think. Okay, so we are either within, you know, have we reached within the waypoint radius of that point? If we have, then we need to do this, right?
For a waypoint navigation library.
Sorry, what was that?
I said, oh, for a waypoint navigation library.
Yeah, we have sort of something like it, right, inside of the mode class. We have a few functions that we've written, but it's not organized into a library as such. Not a standalone library anyway. Okay, so here we are. So we're checking if we've gotten to the waypoint, and if we are, then we're setting the load point to be true. So then the next time through, it should load up the next point, if there is one. Right? So that, and then this one, this stop at home is easy. That's, where is it? What is it? Stop vehicle or something? What is it called? Stop rover, stop throttle. Let me just pull it out of here. Stop vehicle, there it is. Keep accidentally falling into copter here. There we are. So this one, super easy. Space there. So the thing that we have not done here is update distance to destination. I don't have that. We don't have this. This is the critical thing. I think we're actually almost there, don't you think?
You'd like to think that.
I think we're almost there.
I think there's some big holes in terms of, you know, the translating the northeast down into lat long and that sort of stuff yet.
Definitely. What I think you have to do here: reach destination. This. That. We're calling these, right? Calc steering to waypoint. We're doing that. Returning, yeah, this is all just stuff that I copied in earlier from regular RTL. So I think this is, we've done all of this. This is all included above. So we're actually getting there now. Okay, so just a couple of things. Okay, so a med version of this. So 3 things to do now. Set desired location, which can accept a 3D vector. Okay. do you think?
Well, I was actually wondering whether we should mimic the names in Articopter to try to bring things a little closer together. But maybe that's a fight for a different day.
Could be. Do we only have one version of the set desired location? A guided version. And we've got a general purpose version. So one inside the mode class, one inside the guided class. I think the guided one just does set some extra state inside of guided mode so that it knows which of the various controllers the user, the caller, wants to use. So this is the one that we need to create. It probably doesn't need to be virtual. I don't think we're going to override it. At least not immediately. So should we call it like Ned? Maybe we'll just get rid of this. Oh, next heading unknown. We should theoretically set this so the vehicle knows whether it needs to slow down or not. But let's leave it in for now. Let's leave it in for now. Maybe we can do something with that. Okay, so in mode.cpp. Okay, so this is going to be, instead of this, it's going to be a const vector 3f. Just the what, destination ned. Does that you want to call it something? Just destination maybe good enough. It should be that, of course. Right. Set desired location. Set desired location. Here we go. Set desired location as an offset from the EKF origin. In, was it in mid frame or something like that? All right, get rid of this. Now I think we're just gonna be simple about this, right? We want to call this one. We're just gonna call this other guy. We're gonna call the existing function. We just need to convert this destination into an offset from the EKF origin. So
EKF origin or home?
EKF origin. At least that's what SmartRTL uses, I believe. It uses. We can have a peek, but I'm pretty sure SmartRTL works just like the rest of Copter. It works completely in the. It uses this. It returns a here we are, right? Returns a position relative to origin, so not home.
Yep, cool. All good.
So it's in meters, which is nice. So we can actually just use the location. It's actually not that hard. We can have a location, which is lock or something like that. Offset. Okay. Yeah, so we need to first. Actually, one other thing, we need to get the EKF origin, right? This is going to be hrefs.get origin. Okay, what do we got here? Okay, so we go into the hrefs object. In case anybody watches this video, as a little bit of background, there are basically two homes or origins. I mean, well, there's a home and there's an origin. The home is the thing that that the user sets that the vehicle returns to when it does an RTL normally. So that is a lat long altitude, and the user can move it around. So it's a movable kind of thing. Then there's an EKF origin, and an EKF origin is set once and generally doesn't move. It is what the EKF, whenever the EKF is doing all of its position estimation, etc., it internally is always using this EKF origin. So basically it never moves. So your home can move around, but your EKF origin cannot. So yeah, the two different concepts, two different things. We just, it's something that we need to be careful of, that we always use the right one, because quite often they're close together. So it's easy to make a mistake and use the wrong one and not really notice for a while. Okay, so here we are here, and so we need to get origin. We should do like a get origin. Get EKF origin. How do we get the origin? How do we get the origin? There's a set origin. That's not what we want. There's a get home. Where is the get origin? And why do we need it? This allows you to get your position from the origin, your current position from the origin.
There's an example in GCS mavlink.cdp line 882. Rover AHRS get origin, EKF origin as a parameter.
Very nice. Okay, so is that in the Rover code or in the library?
Yeah. Line 882 in GCS mavlink.cdp.
Awesome, thank you. So was that line 888 you said?
882.
There it is. Beautiful. Back we go. To mode.cpp. That's what we want. Of course, what do we do if it fails? That would be an odd thing. What on earth would we do there? Theoretically, we should do this, right? Because it could fail, theoretically.
Yes, it could fail. But, if you don't have your origin, you're not going to be navigating anyway, so
yeah, it shouldn't.
Paul's going to have to handle that case anyway.
Shouldn't ever happen. Shouldn't ever happen. Don't really want to handle it, but theoretically it could happen. So, give me a few too many things here. Get rid of some of these windows. Okay, we'll handle it. So, mode.h, make this return a bool. Set desired location as an offset from the EKF origin. Returns false if EKF origin. Okay, just say that. Or we could be positive. Success. Okay. There we go. Okay. Next, in AP Common, we have a class. I think it's AP Common or is it AP Math? I think it's here. This is the location class. So inside of AP Math, we have functions for dealing with an offset. There we are, location offset. So we just take this. We will use this here. Well, we could use this. It's a bit. This would be kind of odd, but we could do this. and then destination dot x. Dot y. There. So now that has now been updated. Let's just say, let's just call it like this instead. I will comment here init destination to get origin, y set to get origin. So there we go. So that, and then there we go. That looks reasonable. It might work. Ah, of course, return true. Back in here, we've got this guy, which is good. Of course, we don't. Whoops. Excuse me. There we are. So this guy's here, but we need to now check his return value. So one of two things we can do. We can either do this, in which case it will just loop. You know, if in the very unlikely case that it ever failed to set the destination, it would continuously loop, which is not necessarily good. What do you think about this? What do you think about this? How about, we don't want to load the point over and over again, so we can't just do that. We could do this. Technically a failure though. And we really should, you know, send a message to the ground station, you know, and log an error. It's incredibly unlikely. In fact, I think it's pretty much impossible for this to ever happen. I think I'll just add a comment here for now. Add warning to user failure. Add warning and user and log failure. There we go. What do you think, Peter? Still there?
Yeah, I'm still here. I was just thinking you might want a separate kind of an error case to handle that thing.
Sure. It's not hard to add.
Yeah, and the other thing is just know that it's absolutely trivial to send a message to the ground control station. It's gcs.sendText and you're done.
Yeah. Any different already. Okay, and we will set like that. next thing that we also need to do is I think we need to change this. Oh, sorry, not reach destination. This one. Return distance to destination. So I guess we could call this, we could either calculate this each time this is called, or we could just, update this variable all the time. Well, normally we update that number, so maybe we should try and do that. We've done this now. I think we do need this to be two separate cases, actually. So that we can, but this should go up here, actually. Yes. Do you want the SmartRTL at the front? Okay. The last thing we just need to do is just update. And we go down every iteration, which is quite, a bit more than is really necessary, but so we really want to, we need to do this, we need to actually get the home position from SmartRTL and then calculate the distance between our current location and that the SmartRTL's home. I wonder if we can even get that. So it's this, right? It's get point. We don't have a method at the moment to get home. We could add it, or we just do a little. I think we should add it. What do you think, Peter?
It's unclear to me why Copter didn't need it, or maybe it already has something equivalent already in its code.
Maybe Copter is reporting its distance to the next intermediate point instead of its point home, instead of the home point, maybe, or maybe it just cheats and calculates the distance to the actual home. My feeling is that in Copter, when it's reporting to the ground station about its distance to the target, it is just using the intermediate points. So, if you're looking on the ground station map, what you would see is not a line to home, but rather a line to the next point that it's driving to, which is not terrible, actually. The good thing about doing it that way is you can, it's gonna make a very curved path on its way home, right? It might do all kinds of weird maneuvers as it gets home, and so the little line that extends from the vehicle on the ground station map, that would point, to the next point that it's going to, not to home, which probably makes more sense, actually, doesn't it?
I have seen in, I think, Mission Planner, it actually has like 3 different lines, one to the next waypoint, one to the final destination and stuff like that. I haven't actually studied what each of the lines are, but I have seen that in the interfaces. So.
Okay, I think we should stick with, I don't think we want to make this a pointer to home, actually. I think we want to update this, but we don't want to make it a pointer to home. I think we want to make it the distance to this next point. Now, how are we going to get that distance? We've got it right here. We've got it right here. So we should just back out that stuff that we did. We should put this here. Take that. I think this is going to work now. There we go. There we go. Now we're updating this as we're moving. Distance to destination is being updated with the the distance to the intermediate point, which is I think what we want. Okay. I think we're done. 2.5 hours. Oops, didn't compile though. Okay. HRS is private. Maybe we have a different, probably using the wrong one, right? There's probably like a local, the mode has got an HRS, which is fine. Which HRS did we use? Where's mode.cpp? Here we go. Let's move that over here. Yeah, okay, so we try to use the Rover.HRS. We can just use our own local one. Try that again. All right, some more problems, obviously. Again, what is it, an underscore HRS? What is it? What is it? We must be using it somewhere else in here. There it is. Why didn't that work? Maybe because we didn't make it part of the mode class.
Given how well kind of Rovers work for indoor work, it's kind of surprising this functionality is not there yet.
You mean the ability to set a destination using the NED? Is that what you mean, or the SmartRTL, just in general?
The NED stuff.
Yeah. Yeah, it's a little funny that Guided doesn't have it. I would have thought Guided would. You know, we've done some work on Guided, and it's got a bunch of controls here. You can set your desired location as a lat and lawn, but it seems we don't have.
Yeah, I had a quick peek earlier to see if it was doing what we needed it to do, but didn't find it there. So
I'm sure we're going to need that. Again, man, I can't get any luck here. What is going on? Why can't I get this to work? Because I didn't save the file. There you go. Some commits here already, so I'm going to have to squash them all together in a second. Oh, that's looking very good. Oh, no, it's not. No member called get origin. Really? Let me guess. It's because it is the wrong type, isn't it?
I'm wondering whether it's you need a nav EKF.
Yes, exactly. Exactly. So then we need to actually either, yes, switch the HRS type that's in the mode class to be the nav EKF, or we need to add this get origin to the top level AHRS class, one of the two. Let's see here. What is the? I vote for passing. What do you think, Peter? Vote for easier solution is just to pass in the other type of EKF, right? The other type of HRS.
Yes, but I'm not sure the top level Rover has a nav EKF. It's maybe HRS.
Well, it must. Yeah, but this guy definitely has one somehow. This one's got it. So, okay, all right. Let's see what's going on here. So we can either have. So here's our HRSs. This is the rover.h, and we're looking at the, here we go. So this is where we decide whether or not we're going to use the old DCM or the new EKF.
So you'd have to swipe that hash if there to and put it into the mode.h, I think.
Yeah, the only problem with that is that then, yeah, I guess one way or the other, it's not going to compile if you don't have an EKF, right?
Well, that's the thing. If you take the APHRS reference that's in mode.h and just put that hash if around it to maybe make it a NaviKF if NaviKF is available.
Yeah. Okay.
Oh, here it is. Yeah, I see it now.
All right, we got Tom. Tom is here now.
Oh, hello.
We're 3 hours in already. We're hopefully nearing the final stretch.
You guys,
SmartRTL or SmartRTL to Rover, but we're not quite there yet. It's a little bit of a challenge. Okay, so you think in the mode class definition, Peter, we need to.
Yeah, it's not necessarily the best solution, but if you just in mode.h, if NaviKF is available, then do basically what we do in rover.h.
I see. So, okay. Sorry, I'm just thinking about this.
On the other hand, if we do that,
yeah,
and NaviKF is not available, then you'll just get a compilation error around the whole SafeRTL thing.
so something like this, right? So we have basically this here, and this here is what you're saying, right? Like this.
Yes. However, the problem is if NaviKF is not available, you'll just get a compilation error because the method's not found. So if somebody wants to compile Rover without NaviKF in for some reason, they'll get a compilation error.
Yeah. So we could, it's a bit crappy. We could, but we could do this. So now it'll just SafeRTL just won't work.
Yes, you'll compile, but you won't work. To make it a little nicer, you'd probably put that hash if in the enter function and just refuse to enter the SmartRTL mode. It makes it a little nicer at least.
Yeah, so then here right at the top, SmartRTL requires if and this return false, or that'll. What do you think? Should we try and can we try and do it like this? Should we could also do it like this, right? Like this.
My audio working?
It is.
Okay, so you had that option backwards, right? Don't you say if it's not available, return?
If it's not available, we return false, which should stop us from entering the mode.
Right.
And this thing, sorry, just as a side note, do we need to set this? I don't think we. I think, maybe we do this. Maybe we just do this, and I think maybe we'll do that. What is it? Fall through? Is that what we call it? Fall through or something like that? Right here?
Yes. I'm totally doing this tomorrow. I'm gonna write this CAN driver and do a pair programming with crowdsource like this.
Cool. It's a little. I've had some technical difficulties at the beginning here, so we'll have to see how useful it really is. But at least it was a good.
The fall through requires 2 left square brackets on the left and 2 right square brackets on the right.
Sorry, I'm not quite sure what you mean. Like this? No, I can't. That can't be right. I'm just gonna do it like this. Let's just.
Randy, I noticed that you just compile and keep going like this. I found to compile within Eclipse using the make here is really terrible and slow.
Oh, really?
I've actually changed. I changed my workflow so that I have a bash window in the back that I just periodically run the sim vehicle, and have that, and that compiles a lot faster with WAF.
Really? Okay.
And so that tells me, at least for most things I'm working on, it'll tell me for compile failures at least. I can't click on it to jump somewhere, but it's usually pretty obvious where the problems are.
Yeah. Okay. All right.
And
so we're still messed up here. I'll bet you that this is not defined in the mode. Bet you this one's not defined. What do you think, Peter?
Yeah, I think that's entirely possible. There's actually another solution you could consider, I guess, which is there's a interestingly on API HRS there's a set origin, but there's no get origin. The set origin returns false. You could have get origin in there as well, I guess, and it just returns false as well.
Yeah, that sounds like a good idea. You know, I need to take another break, so I will be back in just a couple of minutes. Okay, not 10 minutes. Just yeah, I think you're right, Peter, about the we should just add a get origin to the HRS. I think that's a lot better. And we will add a little check at the top of. Well, anyway, let's add it. Okay, so HRS right here. Get origin. We don't have an origin here. I'm not gonna have one here. So the view. This one must have a get origin, right? We're going to make this an override? That's what we're going to do, right?
Should be. Oh, hang on, aren't you in the base class there? No, you're in NavKF. It should already have a get origin.
I added the override in the end there. That's all.
Oh, yes, you're right.
So that's already there.
That's cool.
So I want this view. Okay, let's have this. We have a set origin. We got this. There we go. Our little guy here. We're going to make him virtual. Const. Oops. It's going to be const. Which one has to return false. Here it says. The inner.
I think you could of course use, if you can't get origin, then use home and stuff like that.
Yeah, but you know, then somebody starts moving it around, and yeah, I agree. It's possible,
yeah,
but
if you don't have a NavKF, that's all you've got.
Yeah. So maybe that'll do it. So let's go back and get rid of that stuff we added here. But we still probably want to check do this. It's a bit weird, but let's do this. Origin, right? How's that? Okay. Then we added some extra stuff around here, didn't we? So let's get rid of this again. We were at before, and then let's give it another try. Oh, we lost Tom, did we? Tom, he disappeared. Must be getting late there.
Yeah, no Tom here.
So it's been, what, 3, 4 hours now?
Maybe we should have chosen something a little simpler. On the other hand, you know, once
4
this is in,
hours.
it's actually an absolutely useful thing for people to use. So it's not just a demo, a toy mode here.
Yes. Yeah, maybe we should have stuck with the heading mode. That would have been less than 1 hour. We could try again.
Indeed, there's no reason we can't do another one of these. And you know, now the audio is now perfectly clear as well, which is nice.
Weird, isn't it? Yeah. Okay. So what have we done here? SmartRTL. Wait for path cleanup. When did I think that was going to be right? Right. That's right. This looks okay. Is not a member of Mode SmartRTL state. What is? That's weird, isn't it? Stuff at the beginning. Here. Wait for plat cleanup is right there. Is it protected? That shouldn't matter. Obviously, we're inside.
You might not need the SmartRTL state component in the name. So you've got mode SmartRTL state, followed by SmartRTL wait for path cleanup. So I don't think you need that middle one. So in the invocation in the CVP file,
you don't need this.
Cut out that. Yep.
Let's try it again. Not a member. Do you think it matters that he's hidden away inside of the protected area?
Shouldn't matter, I'm pretty sure.
Shouldn't matter. Is this enter function is here? It's funny, isn't it? Do I need to? Does it need to be like? What's going on? Mode SmartRTL.
Oh, just get rid of the entire namespacing. You're already in that class. Just refer to it straight as
Like this.
SmartRTL underscore wait for path cleanup.
Yeah, you'd think. I'm pretty sure that was failing before too, but.
And you're using it in the case statement in the same way, so you know.
That's true. He seems happy over here. Yeah, he must be right. That is so weird. There must be some. What the hell is going on here? Definitely, I don't do something like this, right? No way to do like something like this or something, right?
Just make sure that function is actually namespaced appropriately. I would have to guess it is. So yeah, mode SmartRTL. Oh, hang on. No, I don't. I'm gonna try it. I don't think that's correct, but
I don't think that's even syntactically correct. Is it cleanups? Is it clean up versus clean up? Cheapers. Here's our problem.
oh my.
Cleanups. There we go. Now he's happy. Well, Eclipse is happy anyway. I'm sure all the viewers at home will love
Might want to
watching us
see
fight
if that
for that. Sorry, go
one
on.
down below. Just check that one down below. Make sure it's singular as well. Yeah, it's singular.
Yeah. Okay.
Next problem.
Oh, we got something else here. Off-board control minus are not declared in the scope. What the hell is that? That is
Typo.
That is totally random. That's down in a completely different layer that we're not even looking at now. Okay. Sorry, it's still doing something. Maybe I've been flicking back and forth between V2 and V3. Maybe that's a problem. Let's do V3. Okay, let's, while that's happening, let's see if we can clean up some of these commits here. Okay, that looks out of date. Okay, so AP HRS add set origin method. Oops. Origin method. Parent, wow. Okay. That's not good. We've left this. Don't want this here anymore. This is not good. That. Set desired location or destination. Location. Right. Okay, and then finally we just got our. Okay, let's just do this now. Rover. This is the complete SmartRTL integration. Then we're just going to have a quick peek at let's have a quick peek at these commits here. Actually, I should look at it here. Let's look at it here. And so we just need to squash these guys together, these three, and squash these two guys together. Yeah, let's squash these guys together. Actually, you know what? I'm not going to squash them together just yet. I'm just going to push them all up. And then we're going to test this thing. So I'm using a Ubuntu virtual machine. You can apparently run a simulator on Windows, but I never do. So I have a slightly awkward setup in that I generally build and edit on Windows, but then test on Ubuntu virtual machine. Some of the other developers, like Leonard, test it on Windows directly, which is probably better, but to each his own. Okay, so all right, so over here on my machine, I will check out this Rover SmartRTL branch. Then I'm going to go into the APM Rover directory and right, let's see if that compiles. Strangely, the compile works much faster on a virtual machine, on a virtual Ubuntu machine running on Windows than it does on Windows without the virtual machine. So I'll find out much quicker here than I would. Just 1 second, please. Sorry about that, got a little distracted. Now it seems to be, let's see, how's it doing? Looks like it's, oh, failed.
Hasn't found set desired location.
Yeah, almost got there. This one still hasn't even figured it out yet. All right, so something wrong with the set desired location. Because it's set desired location ned, that's what it wants. Set desired location nedo. There we go. Let's see, I'll over here. Oh, okay, here we go. So, got our little rover now. Just make this a little smaller. Mode 1, what is that going to be in? So let's go to stabilize. Sorry, not stabilize, manual. There we are. Arm throttle. Wait for the GPS to settle. There it is. So arm throttle. I mean, it's unlikely to work the first time around, right? Things never do. There goes our little rover driving off. Whoopsie daisy. I'm going to go backwards for a moment. Then we're going to make it steer left. Whoa. To the loop. It's very sensitive steering. There we go. Do some little maneuvers. Let's not try and get too complicated because it's probably not going to work. Okay, so let's then slow down. Oops, now I'm going to go backwards. There we go. Okay, so now to initiate this new mode, we should be able to just type in mode and then the number, which is what, 12?
Yes, it was 12.
Well, okay, so let's see what happens. Failed to set destination. Darn. Now it actually went into the mode, but it failed. Regular RTL will work, of course. Failed to set destination. What happened, I wonder? That error should never happen. It's this one. So what that means is that it somehow is not getting through to the EKF at origin, right? This
Maybe EKF origin is not set.
it must be set.
Mm-hmm.
It must be set.
Well, either not set or we're failing to fetch it for some reason. They're the only two options here.
Maybe it's not calling through to the child class, maybe. How about that? Inside the HRS.
It should. It should. So could just set a breakpoint on that line and see what does get called.
See this one here, right? So this, I think, for some reason, is not calling this get origin, but it does have an override there.
Yes.
If it didn't have an override, I can imagine it wouldn't call through to it. I just wonder if there's something, some reason why it's not calling through. There's no get origin in this thing, right? Not sure what this HRSU, I know it's related to the VTOLs, but I'm not quite sure what relates to everything. I don't think it does relate to it at all, actually. This doesn't work. Heck. Get origin is not working. It must know that I don't know. I'm not sure. Sorry. I guess you probably have a better idea of what to do here than I do, Peter. This doesn't work. I just don't understand that.
Was EKF origin set?
You think it might not have been
say
set? That it was too early, maybe? I didn't give it enough time, maybe, or something?
I'm thinking that we do a lot of checking for GPS, but we don't necessarily check that the EKF is entirely happy.
Right.
So
Okay.
you want to see EKF origin set from GPS or whatever it says.
Okay. Sorry, I'm just looking around at some other stuff. I have this inside of the attitude controller. We have this get forward speed, and I'm pretty sure this relies upon the EKF. Now, it just get velocity ned. Right, this one. It's a bit similar, I think, in that get velocity ned when you just get forward speed. get velocity ned is.
DCM will quite happily give you a velocity in ned though.
Will it?
It's the
looks
the
like-
origin.
Look, it doesn't. Only the only one that implements the get velocity ned is the nav EKF. We don't need something like this, right? This is probably already in the get origin. Sorry, maybe I'm going down the wrong path here. Maybe I'm just. It's already got this stuff in here. Okay, all right, okay, so I'm not quite sure what's happening. All right, so let's just, I mean, surely, okay, so should we try driving around the steering mode instead for a second? Steering mode's not even working. So I wonder if we've got something else going on here. Steering mode isn't working. So that's a bit weird. Let's just try. Just want to make sure we're not bouncing into other issues that may already be, maybe unrelated to our SmartRTL. I think I've seen in my own testing that I think I've seen some issues where steering mode wasn't working in regular motors. I just want to make sure that that's not related. So let's just, here's steering mode. So we're in a skid steering vehicle now instead. Okay, so we've got a home now. Look at that, we're not moving. We're not moving. We are turning, but we're not moving. What the heck? So for some weird reason, steering mode seems broken. I wonder if that's been broken in master. Let's see.
For getting, just to confirm, you do actually step into the correct function for get origin.
Oh,
Just run
okay.
it here.
Well, that's odd, isn't it? Did we make some kind of silly mistake inside of the inside of our function? Where our mode is maybe like always returning false or something like that? Never returns true.
I do hit the failure case, which is quite interesting.
You
Failed
are
to set
just
destination. So it looks the EKF is actually failing to return us our origin. That get origin call on the EKF isn't returning returning us an origin. I'll have to step through it again to work out why.
Okay, great. Hmm. Oh my goodness. So steering mode looks like it's not running in, how can this be? I wonder if we've broken it recently in master. Or have we messed up our parameters somehow?
Oh my, you won't believe it.
What?
Have a look on line 52 very carefully.
Which SmartRTL?
Mode SmartRTL.cpp line 52.
Mode SmartRTL. Mode SmartRTL. Control SmartRTL. Mode SmartRTL. Line 52?
Yep.
Oh. Oops.
See that? See the
Oops. There we go. So when you work, you don't work. When you work, you fail. Okay. Well, that's interesting. Great. I'm a little concerned about why steering wheel doesn't work in master, but this is a bit of a concern.
Look at that.
So we don't seem to move in steering mode anymore.
You're going backwards.
Yes, you're right. It does move backwards well. Look at this. It doesn't move forwards though. So I think we've broken steering mode in master, which is a bit of a distraction. Okay, so.
So when you say master, you're talking about what about master, not the impending 3.2, right?
It's master. It's not.
So the obvious fix is just to merge the 3.2 branch.
Oh. Yeah. Well, we don't really need steering mode to work anyway for this particular thing. I assume that auto mode is still working, so we'll go back and fix steering mode afterwards. So let's just try this Rover. What is it? SmartRTL? Is that what it's called, the branch? Okay, git stash apply stash at 0. So we stashed away some fixes a moment ago.
Stash actually infers the top thing on the stack, by the way. You just go git stash pop or whatever.
All right, okay. Cool. And this line is the broken one. So it's broken in two ways. We made the same mistake on two lines. Sorry, made two mistakes on the same line. So mode SmartRTL. This is the NED. So it should be not. Two mistakes on one line. That's well done. You have to work hard to get that. Okay, let's see.
All right, so the desired throttle is 0 in steering.
Always?
Well, in the case that I'm currently looking at, which is where I've got the throttle at 100%
Weird.
input.
Is it possible? Well, we must have done a patch recently where we messed this up somehow. Maybe we've got like a control in. Oh, you know what? There was a. I definitely noticed. I messed around with this recently. I'm sure I broke this. Just the other day, when we added the pilot, I automatically go to copter. I'm so used to quadcopter. I am sure that the other day, when we did this stuff, I bet you in here we messed up. I bet you this target speed is not being set. No, there it is there. I don't know, but I know we messed around with this the other day. So I suspect we being me, of course, messed this up somehow. It's not immediately obvious to me how we did that, but you're saying this desired steering is always 0?
I'm just having a look.
Maybe the failsafe.
The steering type is 0. Appears to be default. Throttle out is simply get control in. So throttle out, I'm just looking in that get pilot desired throttle and steering.
It should be 0, right? Shouldn't be much to it.
The throttle out is 0. Rover channel throttle get control in appears to be returning 0.
Isn't that weird? Why would that be?
And why doesn't manual suffer from the same problem?
Yes, very strange.
Yeah, get control in is definitely returning 0.
But steering is not 0, right?
Oh, bother. Give me a moment. No, my mistake. I actually had the thing at 0 throttle while I was doing all that.
Okay. Yep. Cool. All right. Let's see if this works here. So let's do arm throttle. RC3 1800. Drive forward. We'll do a little bit of turning to make it slightly interesting. Now we're going to skid steer and get rover, so it's really slow. And turn back straight again. Turn right a little bit. Okay, and then mode 12. Here we go. Mode 12. Surely it won't work. Oh, there it goes. Look at that. Is that working? That looks like it's working to me.
That's scary.
Isn't that scary? It's working. Will it do the right thing? There it goes. Look. Look at
That probably could have been that's awesome. Look at that curve.
Yeah, let's do something a little more complicated. Let's drive this rover as fast as it'll go. And let's do a loop. How about that? That'll be exciting. All right, oops, it's going to disappear. Make it do a little loop. It's going to do a little loop.
All right, this actually puzzled me the other day. Why is target speed based on desired steering?
Whoa, wait, target speed is based on steering?
Yep, line 10 of mode steering.cpp.
That's a bug. That's just a straight out bug, I'm afraid. Okay, so let's try it again. That's just a bug. So here it goes. All right, so it's turned around very quickly. It's heading home. There's a little loop right here. Oh, there you go. See that? It chopped out the path. It pruned the loop. Look at that. We've done it, Peter.
That's awesome.
Awesome.
Well done, Randy.
Yes, congratulations. Congratulations. Here we go. Now it actually stays in the mode. Is that what we do?
Drop to hold, I think, is the
yeah, exactly
thing.
Yeah, so we need to fix that. Let's fix that.
Rover doesn't change though. Sorry, Copter doesn't change out of the mode though, does it?
No, it stays. It stays in. In general, we don't like to. I resisted changing modes unless I really needed to.
I don't think it's actually sensible anyway, because it's possible somebody may wish to do something after SmartRTL is complete.
Yeah.
So, for example, if you were to use SmartRTL as a mission item somehow.
Yes, that's true. Yeah. Yeah, it looks like actually in RTL the switch to hold mode is not handled as part of the mode itself. So that must be done outside. There must be like a do RTL and then it's somehow switching it. Okay. Well, the only other thing is it's not sending the message in case, or is it? There's in Copter when RTL, say when SmartRTL is not going to work, it tells you when you arm the vehicle. It spits out a failure message. I think we actually did add that, didn't we? I'm pretty sure we did.
In enter.
Is it here? Save position, that's okay. Where was it? Here? No. Where the heck is the arming? Sorry, I'm lost. Where's the arming? Is that in the arming of Rover is what? Where is that? Where's the init arm in Rover? Is that in
search for update _ arm state, I think it is.
in system? Nope, not there. Didn't find that. Maybe I typed in correctly. There's the init. There's the startup ground, set mode, startup minus ground. Here's our motors. Here we are. All right. So this we do not reset path. So in Copter we do something. We send a message, I'm sure. SmartRTL is going to be disabled. Maybe it comes out of the library, actually. I bet you it comes out of the library. We don't have to do anything, I think. I think it's in the library. But let's just have a quick peek. I think we're worrying about nothing here. I think it's in. There we are. Reset path. Sends a message, failed to save initial point or something like that. Deactivate. So yeah, so it's all good. Okay, cool, it's good. It's good. All right, so last thing is just to patch these little mistakes. We're gonna merge this guy in. There's nothing else, right? That's the only one, I think. Just gonna merge this in. Okay, so let us squeeze and squash commits together. Okay, we are get rebase minus I head 20 commits. Okay, Okay, add the, okay, we need to squish this guy together. Let's squish this. That's okay. That's way back at the beginning. Plus fits. Set destination. Ned. Okay, let's see what happens when we merge all these together. Okay. See what our commits look like now. Use K as well, another tool. Just maybe quicker than source tree. So that's good. This is add our skeleton class, add the smart library, integrate the smart library. Okay, so these two need to be merged together. And then this one. All right, so these two should be merged. And then this one should be merged, I think. Okay.
All right, I've created a pull request to fix that steering bug. I've dropped a link into Skype for you.
Thank you very much. And merge all these guys together. Okay, let's do that. Hopefully I haven't over squashed things. Okay, so this is easy. Boom, and this is the big one. Okay, so there we go. That is that. That is that. So because it's pair programming, we should share the glory here. So let's, which commit should we give here? Who wants the big one?
It's all good.
Can I get your, where's your?
Now, if RGPilot did the whole signed off by thing, then we'd be talking.
That would be cool. We could do like a shared, is that what you mean? You get like shared commits?
Oh,
Hey,
kinda, yeah.
Can you put your, oh, there you are. This is what you're called right here. This is what you're called. your Git username. All right, so we're going to
Yeah, I think you can actually set the author to a comma separated list with Git. So the author goes in as say example Randy and Peter, and then the committer is Randy.
Oh, really? You can do that?
Yeah, I believe so. I know. I'm pretty sure that's you get commit dash author or something.
Okay. That's cool. Well, we're gonna commit, amend author, and then your Q in here. Hit continue. Again. Let's continue. The last one you're saying that you can do it as a comma separated list, huh?
I think so. I think it's just free text. I'm not sure.
Should we try? So this is what this is me. Okay, so git commit amend author, and we will just try putting two of them in. I wonder if I should have a space separating them. Maybe yes. Probably not, right? Let's see what happens. Right. Let's see what it looks like. Well, it's got us both there, I think. What does it? No, it just got you.
It's got you as the committer and me as the author, which is good. But did you put a comma separated list on that specific commit?
Didn't I?
I don't know.
I think so. I'll do this. Here's the commit. Here's the big one. Maybe we should ask Google. Maybe Google knows. Maybe the internet knows. Commit multiple authors. There we go.
Yeah, Stack Overflow.
No. You do it twice.
Kind of bizarre that the comma separator list just dropped off everything after the comma.
It is a bit weird, isn't it? Should we try this again?
Yeah.
Let's see what happens if we instead do this. See now what it looks like. I'm using multiple tools to do the same thing. Moments in time. Now it looks to me like it's just me. Now it's just me.
Try git show on the thing.
Nope, just got me as the author. That didn't work. That was some bum advice from the internet. Let's see if it has anything else. I see. It just talks about a committer, and an author. I see. So you can put in two names. Well, I don't see how to do it exactly.
Oh well, that matters not. And Michael thinks they managed to do something with the AP landing code along those lines. So.
He's a big one. I'll take the 2 small ones.
So I assume GitHub, where it shows this person committed with that person, is author and committer.
Yep.
When you just picks up a tiny bit in a commit or whatever, preserves the author but changes the committer.
Okay. And then we're going to push this all in. Just have one last little look here. And let's see here, where did it go? So there we go. So we got our little here. So you got a big one, I got the 3 little ones, which I think is cool. We're all here. Just having a final look before I do the forced push. Adding it in. Here's the big one. Okay, forced pushing. In it goes. Do one final little compile to make sure that's working. It's all good. All right, and then we're going to create the pull request.
So it can run the gauntlet of Pierre and Francisco.
Yes, indeed. So there's our, just come here to RTPilot on GitHub. The branch that I've just updated, conveniently appears right here. And we just push that. And we always start our PRs with something like the vehicle or the library that's being affected. We will add the Rover label and the enhancement, although it doesn't really matter. We'll, who should we get? Who should we get? Well, it's okay. What should we say? What should we say here? Is there anything to say? I mean, it's pretty self-evident how it's going to work.
Yeah, I think a lot of my stuff's self-explanatory too, but I've already been taken to task once today for not giving a good description.
Okay, I'll try here. In line with its implementation in Copter. Okay.
Could probably make a note that it's only been tested when EKF is present.
Right, yep. New mode relies on the EKF. It does not work with BCM. New mode SmartRTL class added, which on the SmartRTL library and updates the application or something like that. APHRS gets a new origin required because SmartRTL library provides points some stuff from ECAP origin. Of course, we could have changed that. I guess we could have. We know the SmartRTL library has a ECAP origin, so we actually probably could have enhanced the SmartRTL library to provide the points as a lat lon instead. That would have been another approach, but we didn't do that. Anything else you want to say?
No, it's looking good.
There it goes. And yes, we can come back in 30 minutes or so, and if all has gone well, this little scene, Travis, check it out, run it through our centralized build server, make sure it builds for all boards, and also run it through a whole bunch of CIDL tests. Those CIDL tests at the moment do not actually test SmartRTL, so it'll just ensure that we haven't broken some other obvious things like navigation, etc. But yeah, basically I think we're done. That took in total 4 hours or 5 hours? 5 hours.
5 hours.
5 hours, but well worth it, I'd say. That's a pretty impressive new feature, I'd say.
Yeah.
Not to brag or anything, but I think we did pretty well there.
Ticks the box, gets one of those issues ticked off. So.
Yep. All right. Well, thank you very much, Peter. And if anybody managed to watch the video and get this far, well done.
Thanks for listening, and thanks for Andy. That was enjoyable.
Yeah. Talk to you later. See ya.
Bye.